here's a diagram of the carbon cycle. All right, let's talk through this. Atmospheric carbon dioxide. Let's write that one in. Atmospheric CO2. How does it get here? All right, how do we have atmospheric carbon dioxide in the first place? I mean, we know we do. Firstly, we've been pumping it out through burning fossil fuels, so that's rather an issue at the moment. But there's always natural carbon dioxide in the atmosphere anyway. In fact, this has actually saved the planet twice over. A couple of times the Earth has gone into what is essentially what is referred to as the Snowball Earth theory. It's basically a completely frozen over Earth. Now, we were actually saved. Who were we saved by? The guys over on the left over here, the volcanoes. So what we have is we get atmospheric CO2 from the interior of the Earth. So we're talking coming out of volcanoes. Lots of stuff comes out of volcanoes. One of those things that come out of a volcano, apart from the very obvious magma, then we change its name and call it lava, is CO2. Okay, so we get CO2 coming out of volcanoes, and like I say, that actually saved us a couple of times from the Snowball Earth. CO2, there was so much volcanism and so much CO2 release that the temperature of the planet warmed up and melted a lot of the ice. So yay, the Earth is not completely frozen over anymore. Cool, grand. So we've got some atmospheric CO2. Well, who's going to take that up? We can't really use that, can we? In fact, we have to get rid of it. We make it through our metabolism, right? Just by doing respiration, but we have to breathe it out. Yeah. The people who do use it, well, not people so much, but the plants, they do a process of photosynthesis. Yeah. So photosynthesis is whereby plants are taking CO2 and water, and they use the sunlight energy, and they make their own food in terms of sugar, and they also give out oxygen, and we're like, oh, awesome, thanks plants. So through photosynthesis, we now have carbon stored in plants, right, in this little tree down here. Now, animals eat the plants. So there we go. So the plants become food for animals, yeah? And of course, once we eat the plants with the carbon, well, now it's in animals as well. That's a little cow here, right? How do you know it's a cow? Because it's saying moo. Right, so we've got carbon compounds in the plants and other carbon compounds in the animals. Now, we both actually do respiration. We talked about photosynthesis, plants doing that. Actually, there are 3 very funky animals that can photosynthesize as well. But generally, that process is saved for the plants. However, both of us, as in the animals and the plants, we both do respiration. Now, a lot of people sort of think, oh yeah, plants do photosynthesis, animals do respiration. That's the difference of us and them. But plants actually do both, right? Cool. Now, unfortunately, those plants and animals are going to die one day. That's just the thing, right? So just to the right of the tree there, of the happy, healthy green and brown tree, we've got a dead-looking black tree and an upside-down cow. So dead organisms. Now, this cow is not just upside down. It actually seems to be floating in the air, but we won't worry too much about that. What we actually have here, though, is death. And not just death, but waste material. So let's put that in. We've got death of organisms, plus we've also got waste material. All right, so that's putting carbon down into the ground. And if we wait for a long enough period of time, well, some of that carbon may well just turn into this stuff, the old fossil fuels. Now, these are, of course, what's causing major issues at the moment because we're burning a lot of this stuff. Now, what do we mean by this stuff when we say fossil fuels? Well, we're talking peat. A lot of people don't really think about that one so much, but the biggies at the moment are coal. We're burning coal, not so great. We're using too much oil, also not so great, burning that. But we've also got things like natural gas. So peat, coal, oil, and natural gas, these fossil fuels. Now, what are we actually doing with those? Well, we're digging them up. And as I mentioned a couple of times now, we are burning them. So on this arrow going up to the factory, we have industrial burning of these fossil fuels. Oh, come on. Oh, pen. What are you doing here? Hang up. Let me get on top of this pen. Right, okay. In dust, and we'll go back to it. Industrial burning of fossil fuels. FF, there we go. Industrial burning of fossil fuels. And when we burn it, that puts carbon dioxide back into the atmosphere, of course. So we're back around to our atmospheric CO2. Now, like I said, we've always got atmospheric CO2. This was what makes rain acidic. I've got a video on that, on how rain is acidic, because that atmospheric CO2 dissolves in the water that's also in the atmosphere, and that gives us H2CO3, carbonic acid, and it rains. And we just call it rain. We don't call it acid rain because it's only weakly acidic. But the pH of standard rain is about 5.6. All right. Now, if you remember the pH scale, 7 is neutral, neither an acid nor a base. More than 7 is a base and less is an acid. So 5.6, rain is slightly acidic, and that's because that atmospheric CO2 gets dissolved in water and falls down as rain. So it is a natural thing, this atmospheric CO2. The issue is that is actually going up, mostly due to the burning of fossil fuels, right? And this, of course, leading to climate change, and it's anthropogenic climate change, which means man-made. So the issue here is that there's so much of this stuff going on. We've got less carbon stored in the earth, and we're releasing it into the atmosphere. So this concentration of atmospheric CO2, let's write that in, the concentration is going up. Wow, that was a really bad arrow. Let's try that again. There we go. Is going up. At the moment, it's over 400 ppm. That's parts per million. Now, when I was at school, and admittedly that was a long time ago, the carbon dioxide in the atmosphere, it was roughly 355, 360. And I remember when the scientists saying, okay, let's 380 ppm parts per million. Let's not go above that. And then we went above that, and then they said, okay, it's 400 parts per million. Let's really try hard, guys. We can't go above that. Yeah, we've gone above that. And as of last year, what was the average for last year? It was like 412 or 411, something like that. Let me just do a quick check on this. Got my Google out here. Atmospheric carbon dioxide. Let's see. What we want to check is the last one from where they tested in Hawaii. Blah 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 blah. It's nearly 412. This says, yeah. So that's what I thought. It was about 411 point something. So 412-ish parts per million. Not so great. A lot of people think, yeah, 412 for every million. That's not really a lot. No, we're not saying the concentration of CO2 in the atmosphere is super, super high. But remember, it will only take a little bit of cyanide to kill you, right? So just because the concentration might not seem like a much, like a really high level, it's actually enough to do really bad stuff. And the really bad stuff is, of course, the climate change that is going on at the moment. Anyway, this is not a video about climate change. It's a video about the carbon cycle. And there it essentially is in basic detail. Cool.